So today we will go over the SAT Practice Exam 10, Modules 1 for questions 14, 20, and 27. So starting off with question 14, it reads, the function f is defined by f of x equals to x minus 6 in brackets times x minus 2 in brackets times x plus 6 in brackets. In the xy plane, the graph of y equals to g of x is the result of translating the graph of y equals to f of x up 4 units. What is the value of g of 0? So, given these two functions, we know that g of x we know that g of x is the result of f of x shifted up 4 units. So what that means is it doesn't really matter what f of x looks like. Like, of course we're given this equation to see what it looks like, but it's too time consuming to plot out the Cartesian coordinates. What is x? At x equals to 0, what is y? At x equals to 1, what is y? At x equals to 2, what is y? So on and so forth. It's too time consuming, especially in the SAT where you only have 35 minutes for, I believe, 20 something questions, 27 questions. It's a bit too much time. So when you think about this question, they also give us g of 0, which is something we can plug x into. And the whole point of this question is to test your understanding on how graphing works and what happens if you translate or when you move a graph a certain way. I don't think this question is asking you, oh, I want you to graph f of x, because that is honestly way too much work. So let's just do like a example curve or example function. So red can represent f of x. I know this doesn't represent the function, the graph properly, but it's just an example standout of what f of x is doing to get g of x. Because you know that g of x is just the graph of y equals to f of x up 4 units. It's essentially saying that the graph itself doesn't change, like the curve itself doesn't change. It just shifts every point. It shifts every point up 4 units along the entire graph. It keeps the entire shape, but it just shifted up 4 units. So given that information, we see that the original point can be found if we know that g of x of g of 0, we can find g of 0 and we can relate that back to f of x because we know it's translated up 4 units. So we can write something like g of x equals to f of x plus 4. Again, f of x often denotes the y coordinate, and g of x is the same thing. So all we need to do is find f of 0, because what the question states is, what is the value of g of 0? So we need to find f of 0, add 4 units to that, and we will find our answer for g of 0. So I'll rewrite the entire equation again. F of x equals to x minus 6, x minus 2, x plus 6. So again, just reviewing from functions, f of 0 just means that you're replacing every single variable x, denoted here, with a 0. So for example, if there was some y constant, or sorry, some y variable, you would just leave it as a y and you wouldn't plug that in with 0, only the x's. So we would get negative 6 times negative 2 times 6, which would equal to 72. So f of 0 goes to 72. And again, plugging this 72 back into here, we see that g of 0 equals to 72 plus 4 equals to 76. And that is our answer. Again, obviously this graph isn't drawn to scale, but all it's saying is that you found f of 0. So f of 0 would be this point right here. This point happened to be 72, and we're just shifting this point up 4 units, and g of 0 equals to 76. I hope the visualization of the graph kind of helps demonstrate what is going on. I think for a lot of students, it's difficult to kind of imagine something. Like, it's difficult for them to imagine what this graph would look like, because they think they would need to see what the graph would look like first to understand these type of questions. But really, it's just recognizing that f of x is the y component. G of x is the y component plus 4 units, because you're shifting the graph of y of x, or the graph of y equals to f of x up 4 units. Okay, so moving on to question 20. This is a system of equations question where you're given 2 lines. So how would this look? This would look, just to give you like a brief visual understanding of this, you're given some xy plane, and you're given these both equations follow the form y equals to mx plus b. Hence we know that they both are equations for a line. Now I don't really want to graph out the 2 lines. I think it's going to take too much time. So we can assume something like one line goes like this, one line goes like this, for example. I don't really know which is which, but we can just assume. And the question states, the solution to the given system of equations is x, y, the coordinates x, y. What is the value of x minus y? So given that information, we can kind of assume that there will be one solution, meaning that the 2 lines will intersect, aka the lines are not parallel, and they are not the same line, just factored differently. So the way to approach these system of equations is that you want to isolate one variable. So notice that in equation 1, which is the top equation, the y variable is already isolated. So we can plug that into equation 2. So let's write that out. We would get 4x plus 1 equals to 15x minus 8. Now, all we need to do is just manipulate this equation and isolate x to find what x equals to. So I'll do that quickly. Should be 16x plus 4 equals to 15x minus 8. Minus both sides by 15x, so we would get x equals to, and then we can minus 4 from both sides. So we would get minus 12. So we've already found what the x component is. Now step 3. Solve for second variable. So all that means is that because we found x, we can plug this x back into either equations and we can find y. This works for either equation 1 or equation 2. But just looking at equation 1, it looks a bit more simple. So I will plug x into equals to negative 12 into that equation. So we will get something like y equals to 4 times negative 12 plus 1. Y would equal to negative 48 plus 1, negative 47. And we found our y. So we found x and y. What does this mean graphically? It simply means that the coordinates x, y is a point at which these two equations intersect. It means it is this point where they intersect. And we found it to be minus 12, minus 47. Now this isn't our final answer because the question states, what is the value of x minus y? So we would do negative 12 minus negative 47. And this would be our final answer, which I think is 35. And this would be my final answer, 35. This question just pretty much tests, are you able to recognize a system of equations, and what do you do given a system of equations? How do you solve it? How do you isolate one variable? Do you know to plug it into the second variable? And I could go a bit deeper into this. As I mentioned earlier, the lines could be running parallel, or they could be the same variable just scaled upwards by a constant. And if that happens, there would either be infinite amount of solutions or no solutions at all. But because this question states that the solution to the given system of equations is x, y, we already know there's going to intersect at one point. Hence, we don't need to check if the equations are parallel or if there's no solution. Okay, the last question. The equation states, what is the sum of the solutions to the given equation? X times x plus 1 in brackets minus 56 equals to 4x times x minus 7 in brackets. So when I read this question and I see that I'm expected to have multiple solutions because it states what is the sum of the solutions to the given equation. So that leads me to think about polynomials and trinomials, because a lot of the times we're given some form ax squared plus bx plus c equals to 0. And oftentimes we can rewrite this as x plus or minus something times x plus or minus something. And these two forms are interchangeable. They both equate to the same thing. One is just an expanded out version of that. So looking at our current equation, it doesn't really look like a trinomial form. So let's try to manipulate it and try to make it into the trinomial form so that we can hopefully find two solutions for x. So let's expand the x out. We have x squared plus x on the left hand side, or minus 56 on the left hand side, equals to 4x squared minus 28x on the right hand side. Let's subtract both sides by x squared and subtract both sides by x. So we would get 4x squared, or sorry, 3x squared minus 29x. And then we're going to add 56 to both sides. So plus 56 equals to 0. And I pre-wrote the quadratic equation because this seems a bit difficult to use the two numbers that add into something and two numbers that multiply into something. So let's instead plug these numbers into the quadratic equation. Again, the first term in front of the x squared is the a variable. The first term in front of the x is the b, and constant is just c. So let's plug that in and see what we get. we would get something like 29 plus or minus square root of b squared, which is a41, I believe. I'll just write negative 29 squared first, minus 4 times a, which is 3, times c, which is 56. All over 2 times a, which is 3, which is 6. And I'm going to pull out a calculator real quick for this. We should get 29, negative 29 squared is 841. So we have 29 plus or minus 841 minus 4 times 3 times 56, which is 672 all over 6. And this equals to 841 minus 672 is 169. Square root of that is 13. So we have 29 plus or minus 13 over 6. So this leads into 2. I'm just splitting up all this term means is that you want to solve one way with addition and you want to solve it the second way with subtraction. So 29 plus 13 equals to 42. And we have 29 minus 13 over 6 equals to 16 over 6, I believe, equals to 8 over 3. Now the question states, what is the sum of the solution? So you want to add these two. We found what x will equal to. X equals to 7 and 8 over 3. All we need to do is add them. So I'll rewrite 7 as 21 over 3 plus 8 over 3 equals to 29 over 3, which is our final answer.